Good afternoon. I'm Dave Lenrow. I work for Huawei, but I'm here today as a ONOS ambassador to talk about the project and the community. So ONOS is an open network operating system. I think, thinking of it as an SDN controller is probably useful. Network operating system, is accurate, but I think SDN controller is what we're talking about today, and it's the same type of beast as Open Daylight, for example. With a mission really service provider specific is one of the things that's unique emphasis in ONOS, and I'll talk more about that. So the history is interesting. This was a project that was originally created by a team that worked for a single company, and the original development of sort of the foundation of the system was done by a relatively small, tightly integrated team. And there are benefits to building things at certain stages with a smaller and a more tightly integrated team. And so there's benefits from having started out that way. But it was released as an open source project, and the source code was first made available in December of 2014. So, like SDN, it is relatively young. Its life as an open source project, somewhat younger. Open Daylight has been available as an open source platform and growing the community longer than ONOS, but ONOS completes the kind of provides a second controller solution and provides choice and competition within the industry. Really, the focus of the community is to try to build solutions with a vertical integration for a specific use case. So rather than sort of trying to go wide and create an enormous number of generic features and services that might be useful for many different use cases, the approach has really been to pick a small number of use cases and build solutions for those that are, end-to-end, complete solutions to solve a problem and that are deployable. The leadership and the governance is now in the control of the Linux Foundation, and there's a lot of work being done in the community and with the foundation to improve the leadership and the governance, particularly by making it more diverse and more community-driven. So this is the process of going from a project developed by a small group of people, very similar to a big, diverse community, meritocracy, all those kinds of good things. That's the process that's going on now, and we're actively working on that. And I think one of the things that distinguishes ONOS is it really worked on providing a toolkit with some really powerful abstractions to make it simpler to build powerful and interesting things and to make developers highly productive. And I'll talk about those a little bit more. So the ONOS ecosystem, consists of the OnLab team who started this project. Originally, a number of major service providers, including some here in China, includes many of the big networking vendors. It includes all kinds of independent organizations that are, involved in building things with it for various reasons, and it completed with sort of anybody and everybody who's interested or wants to participate. Again, it's a completely open project. If you want to participate, it's very easy to do so, and there are a lot of opportunities. So the general goal is to have a quarterly release, and that isn't necessarily always perfectly to the day, but that's the rough cadence. The various releases various releases are named after members of the bird family. And so at this point, the next release that's in the process now and will be coming out in August of this year is the GoldenEye release. And one of the interesting aspects of release planning within ONOS is that before the work on the release starts, the entire community contributes to a list of goals and priorities for that particular release. And so there's sort of some top-down coordination among all of the contributors and among all of the projects to decide what are the priorities, what's important, what are we going to work on together. Not all open source communities work in that manner. Many come from more of a sort of a bottom-up approach where each project figures out what they want to do within their project, and it's completely independent and autonomous. But for the ONOS process, it has been decided that it makes more sense to try to get a small number of focused priorities that all the projects are working towards together in some form or another. So the ONOS focus on service provider networks essentially implies massive scale and a need for really high reliability. Those aren't necessarily requirements for everybody's software-defined network, but they're clearly requirements in service provider networks. So these are just 4 examples of service provider networks that different purposes, different media types, but ultimately, what you see there is, thousands or tens of thousands of routers, tens of thousands or millions of ports. Point being that because of this scale, you need to build things in a way that's fundamentally different than what you can get away with building for other less demanding applications. So they've sort of tackled, what's arguably the biggest, hardest part of the problem. But again, by trying to focus specifically on that, the hope is to make a lot of progress on that very quickly. So I'll give a little bit of a technical overview, and obviously this is a mixed audience, and the complete deep dive into all the technical details probably isn't what people want. So this is going to be a bit of a high-level technology overview, and again, online on the ONOS wiki and other places, there are all sorts of documents and videos and things available that provide a much deeper explanation of the technology from the high level, and then obviously the source code is available for people who want to go to that level. So some of the basic tenets of the architecture, the goals for building the system, as I talked about, it's the carrier demands, it's high availability, scalability, performance. Again, this emphasis on strong abstractions and simplicity, allowing developers to get a hold of things that they can very quickly build useful things out of, and that encapsulate some of that complexity so that every developer doesn't have to understand every aspect of this. Goal is to allow people to develop services and functionality that are protocol and device behavior independent. So the goal is to support multiple protocols and multiple devices, but do it in a way that's as transparent as possible to the developer, so that the developer, again, is thinking about the functionality and the service, not all of the details of the inner workings of every single subsystem. And so it's along those same lines, the separation of concerns and modularity, allowing people to tailor this for their own needs without having to essentially fork the code base and create 2, related but not identical versions of the project. And as I talked about yesterday, kind of the strength of an ecosystem is really a function of how many people are participating in it. And if every time you fork a project, you reduce the size of the ecosystem, by a factor of 2. So really important to allow people to customize this for their needs and not have to do it by taking the project, making a private copy of it, and starting to diverge from the common code base. And so one of the things I talk about a lot is the fact that we're sort of inventing an entirely new IT stack, that consists of things like orchestrators and SDN controllers. We've gone from a world where, sort of the OSI model was the definition of the right way to build things and provided a block diagram, and provided some very clear layering and some very clear rules about the layering, so that when you were handling a link error up in the transport layer, it was obvious to everybody that that's the wrong thing to do, and you're doing that work in the wrong place, and you could sort of explain it with this simple layered chart. As we start to build this new IT stack, there's a danger that we don't have any layering, that we sort of have a giant blob of stuff with no real sense of where things belong or where things don't belong. And so one of the things that we've tried to create within the ONOS project is some specific layering in some way to kind of define where is it that you build things. One of the things I've talked to operators about a lot recently is they want a core that changes infrequently. And then they want things layered on top of the core that will change more frequently. But to completely replace all of the software in your controller in order to get one small feature or bug fix or something like that introduces tremendous risk. And operators are not known to embrace risk and are trying to control things and move very carefully. So one of the really strong demands is, we need some kind of a separation of what is truly the core of the platform from the things that are layered on top of it, and we need to be able to rely on that core changing infrequently and only when absolutely necessary, and having sort of lighter weight things that can be deployed without touching the existing code. If that core has been working perfectly for months, the last thing you want to do is replace 100% of it with something that's going to introduce new bugs and new risks. So you'll see the ONOS platform, starts with this distributed applications platform, which I'll talk more about. Then layered on top of that, you have what is defined as the core of the ONOS platform, and then separate from that and sort of packaged separately are the things they call ONOS applications, which tend to be the specific services and use case supporting code, which come separately. And then I want to make clear these are ONOS applications, but they're not to be confused with user applications or cloud applications or the type of an APP that lives outside of the controller itself and would use the REST API, for example, in order to interact with the controller. And so again, this just highlighting that ONOS applications area, and when we get to a bigger block diagram, start to get a clearer understanding of what exactly falls into the applications category, what's in the core category, and how is that distinction made. And then there are also things called ONOS extensions as opposed to applications. They can also include drivers and protocols and minor changes to things that are in the core in order to allow, again, that stability within the core and a thinner layer of packaged things that sit on top of it that change more frequently. And so obviously at the top of this, there's a RESTful API for sort of the programmatic interface to the controller system, and there's a graphical user interface for sort of direct manipulation of the controller system. There is a command line that works and allows access to things across all of the various ONOS layers. And the goal here is, again, not to tell you graphical interface is good or command line is bad, but to provide all of the systems that people are used to using and let the community and the user base decide what's the best way to interact with the system and where they want to build their functionality. So one of the really critical things that was done in ONOS was to try to hide what is essentially the distributed computing problem. So if you're developing a service that runs on a single ONOS node, or you're developing a service that's distributed across 100 ONOS nodes, the goal is for the developer to not really have to understand that or think about it, and to provide the developer with a world where they can just think again about sort of the functionality, the interactions, and the fact that this might be running across two systems that are separated, possibly in the same building or data center, but just as likely separated geographically in a service provider network. And so this is a really powerful feature, and again, if everyone had to become a distributed systems expert in order to start working in SDN, we would need a lot more highly trained people. We would have a lot smaller pool of potential developers. And so really, I think one of the great strengths of ONOS is this notion that hard distributed computing problems have been hidden in such a way that if you sort of live within the sandbox provided for developers, you can then rely on the system being highly scalable and available and distributed and all those kinds of things. And, you know, part of that is building into the system the kind of self-healing and failover mechanisms that are required so that if an entire ONOS controller node were to fail unexpectedly, the system will transition to rebalancing the control plane load across the remaining systems and continue to operate. And so again, rather than have every single person who's developing an application think about this kind of a failure case and build the handling for this kind of a failure case into their applications code, instead what happens is it's built into the system libraries, and that complexity is hidden. The features and the scalability, the robustness can be changed and enhanced without having to make changes to the applications themselves or other pieces of the system. So again, if you were to look at this, which is essentially 4 ONOS instances or nodes, the applications have this sense that they're just running across one big giant logically single node. The core APIs look as if you're talking to one single, logically single interface. The core lives everywhere, and the southbound API lives everywhere, and so it's really only when you get down to the specific providers and protocols and actually talking to individual switches that any part of the system has to understand the details of which switches am I connected to, how is the system interconnected, things of that nature. So there's lots of animation in here that I don't quite understand, but so the distributed architecture is really, again, I've already previewed some of this, but it's set up as a cluster of instances. It's set up symmetrically so that the same software is running on every single node, and as described, losing a node doesn't cause you to do anything radically different other than rebalance the load. We don't care where the client is in the system, and the system can scale up and down and self-heal as needed based on usage and without complexity for the service developer. So this drills deeper into the core subsystems, and essentially what you see here are some of the core services. And so this is the nature of things. If you look at something like clustering technology, this is a fundamental piece of the system. It's something that shouldn't change because you added a new application or service, and so it's by definition needs to be part of that core. And within the core, you really see the value of the fat SDN controller, as I called it, rather than just something that is an open flow multiplexer. This is something that has all kinds of high-level services, so that if you want to interact with tunnels, if you want to deal with tenants, if you want to look at topology, all of these things are built-in core primitives that are part of the system. The developer doesn't have to understand them, doesn't have to go all the way into all of the details about them. They just have to understand the API and how to use it. And so then up in these, so the blue boxes above that dashed line above the core, that's where the things called ONOS apps live. And so as you can see, they're not apps in the sense of end-user applications like unified communications or media streaming. They're applications in the network sense. It might be IPVPN or a forwarding interface or something that's higher level and built out of the core primitives, but is still likely to be of interest and reused by other applications that actually live outside of the system. So again, you want to provide that REST interface and all of the other interfaces to allow people to build things on top of that. And so some of the key northbound abstractions that have been built inside of ONOS in order to make things easier, there's a network graph notion that gets populated with all of the devices, all of the links between the devices, and all of the end stations, so that that's sort of a perpetual database of information that's kept up to date, and services can rely on having sort of a single, one-stop shopping to understand topology and to track the changes within the topology. Flow objectives are part of this idea that, we'd like to make it easy to program devices without having to understand all the device details. So in this particular case, when you look at an open flow model, there's some kind of a pipeline of table-based processing that goes on. The TTP project that Colin has worked on and talked about sort of allows you to build those different pipelines, but what's becoming clear is that different vendors and different people are going to build those pipelines slightly differently in a different order. So the flow objective is intended to be a higher level of abstraction that talks about, intent-like what you're trying to do rather than the specific details of how to do it in terms of the pipeline. And so this is a way to say, here's what I want to happen, and then some other smart piece of software can figure out how to map your flow objective onto the actual device that it discovered when the system started up, based on the understanding of the pipeline for that device. And then finally, there's something called ONOS intents, which are a abstraction that really allows you to describe connectivity in a way that's independent of the state of the network. So what you don't want to do is have to constantly, up at the applications level, understand where particular endpoints are located and how to put them together. And then if something were to happen within the network, some change of state in the network, to make the application go back and figure that out all over again. So in this case, what you describe is the connectivity, I want A to be connected to B, and then the intent service is responsible for dynamically making that connectivity available regardless of the state of the network. So again, a self-healing kind of a concept. You enable the system to self-heal by using some interface that's abstract enough that it gives the system degrees of freedom to change things. So if you specify all the paths for that connectivity, when something goes wrong, you're going to have to go through and change all the paths, where if you just describe the endpoints, the system can go through and automatically make those changes in real time as state changes within the network. So I think I've talked about all of these in detail before the slides came up. We talked about flow objectives and intents. So here's some examples of applications people are building with ONOS. There's something called SDN-IP peering, or sometimes they'll hear it referred to as IP plus SDN. But really the notion is we want to be able to build a SDN fabric and insert it into the middle of a non-SDN traditional BGP routed network in such a way that it's transparent, so that the existing BGP router hosts look at this fabric and they think they see a BGP routed peer, but inside of the fabric there's actually no routing-based forwarding. It's typically done with open flow and match action types of rules. Multi-level IP and optical provisioning is again kind of recognizing this idea that you really need to control all the levels of the network to provide a useful controller. To say I have one controller for layer 1 and a different controller for layer 3, or things like that, start to cause opportunities for unsynchronized behavior, things of that nature. So a big goal of a lot of people is to have a single controller that can talk both to their IP layer and to their optical layer in a coordinated way to get the best benefits of both. There are some content acquisition and video streaming applications that are being built and deployed. There's a kind of a virtual network gateway concept. and there's a bandwidth calendaring application, essentially a bandwidth on demand, but based on sort of reservation-oriented rather than a more instantaneous approach. And again, because it's an open source project, if any of this is interesting or gets your attention, you don't really have to be confused about where do I learn more about this. Start at onos.org and you'll find a wealth of documentation and examples and things. Thank you.